Hello everybody and welcome! While most of the attention of space enthusiasts is directed towards SpaceX and their Starship development, how cool was that second integrated test flight, right? There's a lot of movement happening over on the other side of the Atlantic, right here in Europe. And some of that was on display when I was at the Space Creator Day back in October at the Technikmuseum Speyer in Germany. Today we'll look at some of the European companies that want to grab a piece of that lucrative new space market, and we will also talk directly to two up-and-coming rocket manufacturers. So make sure you watch until the end so you don't miss that. And if you want to watch a part of it now, another part later, subscribe so you can find it easily again in your subscription feed. First, let's start with Rocket Factory Augsburg. As their name suggests, they are from Germany and they build rockets. I was able to get an interview with Jonas Kellner from RFA and it all went great until I checked the audio file and it got somehow corrupted. So this is going to be more of a narrated interview. The most important thing is they are building RFA One, a micro-launcher that will be able to lift up to 1.3 tons into low Earth orbit or lighter payloads into higher orbits, including up to 150 kilograms to the Moon. Theoretically. The rocket is made out of stainless steel because it is a readily available material and also comparatively cheap. Nevertheless, RFA want to recover the first stage one day via parachutes. But that is something they want to focus on later. First they want to reach orbit. In order to do that, they have already done a bunch of tests, including a fully integrated test of the second stage of RFA One. Another one for the first stage is also planned before they want to do their first ever launch from Zaxford Spaceport in Scotland, currently slated for the second quarter of 2024. The first and second flight are booked by the German space agency DLR, who has selected 7 customers for the inaugural flight. And 10 more commercial customers have already booked for future flights aboard RFA One. Jonas Kellner said in our interview that they have a pipeline in the billion-euro range, so business appears to be booming even without the rocket off the pad yet. One thing that makes RFA interesting is their in-house developed Helix engine. It's the first stage combustion rocket engine developed within the European Union. Compared to an open cycle engine, RFA claims an efficiency increase of 7%, resulting in overall 30% more payload capability, meaning they can sell more flights to potential customers. As with any other rocket company, the engine was one of the most challenging parts of development, but it appears that they have it now in a pretty stable state. Asked whether or not RFA has any ambition to get into the heavy launcher business one day and into competition with Arianespace or SpaceX, Jonas Kellner said that that's not something they are actively concerned with now. First, they need to be able to reach orbit at all, which is understandable. Look at all the other space startups that are currently trying to get up there. Space is hard. I wish I could show you the interview in its entirety, but unfortunately my equipment had something against it, as I said in the beginning. It was a good conversation and I'm very curious how RFA One's first flight is going to turn out. Maybe I need to save up for a ticket to Scotland sometime in the second quarter of next year. Another European company that already has launched is PLD Space from Spain. Their Miura 1 was tested at the beginning of October 2023, but that's not an orbital class rocket. Instead, it is designed to provide suborbital launches, for instance for microgravity experiments. Their orbital rocket Miura 5 is still in development. It should be able to put up to a ton of payload into low Earth orbit or 500 kilograms into a sun-synchronous orbit. On their websites, they give themselves ambitious with a goal of 15 missions per year. And they have already signed a deal with the French space agency CNES to launch from their launch site in French Guiana and plan to operate from a second site as well. Similarly to RFA, they want to recover their first stage by parachute. Coming back to Space Creator Day, there was one more German company that wants to reach orbit soon. Isar Aerospace. Not only did they hand out comfy socks as merchandise during the event, they are building a 2-stage orbital rocket called Spectrum. And I got Tina Schmidt from Isar Aerospace to tell us everything about it. And this time with working audio.
We're here with Isar Aerospace. This is Tina Schmidt from Isar Aerospace. And let's just tell our viewers, what is Isar Aerospace, why is Isar Aerospace, and where is Isar Aerospace going to be in 2 years, 3 years?
All right. So yes, we're a company, we're a space company based in Munich. Like the name says, we're named after the Isar River flowing through Munich. And how we were founded was actually that students, a group of students, 5 years ago, 2018, met at the TUM, at the Technical University in Munich. And they were doing research together for rocket engines. And so the industry approached them and wanted to buy rocket engines from students. And they said, if the industry needs rocket engines, there's definitely also need for a whole launch vehicle. And that's how all of it started. Since 2018, we have developed and grown to a team of 350 people with nearly 50 nationalities. Headquarters and production is close to Munich and Ottobrunn. Our main test site is up in Kiruna in Sweden. And the first launch site that we're going to operate from is in North Norway. So that's going to be opened in 2 weeks from now.
Okay.
And so at the moment we're kind of fully on track with engine development. We're finalizing everything there. We're shortly before starting the engine acceptance testing for the flight engines. And then launch vehicle is going to be brought to Norway, and we're going to do a few more tests, like static fire tests, and then we get it ready for first test flight.
So do you expect the first test flight to happen within the next 6 months already, or is this more something down the line, 2025 or so?
2025, I doubt. So I think we're on a good track. And as I said, the goal is to have the launch vehicle in Norway still this year. So right after that, and depending on how the stage tests go, I think a first test flight right after that is viable.
What you're going to launch is what we see here behind you. Can you walk us just quickly through what this rocket is and what it is capable of?
Sure. So this is our Spectrum launch vehicle. The Spectrum launch vehicle runs on liquid propellants. It runs on liquid oxygen and propane, which is quite a unique propellant combination. All of the development, all the systems that are going on the launch vehicle Spectrum are built in-house, are tested in-house. We do have kind of the same approach that SpaceX also follows, which is a very high vertical integration, because we think that it gives us the maximum flexibility and also a very high speed in actually iterating and developing. We run with 2 stages. First stage runs with 9 engines, and the second stage will run with 1 engine.
That sounds a bit familiar.
Exactly. And the payload capacity that we're going to have is planned with 1 ton for LEO and 700 kilo for SSO.
Do you also plan, like Falcon 9, to land the first stage again after using it?
So for the first few flights, there's not going to be any reusability, but the Spectrum and all of the systems are definitely designed with reusability in mind. Reusability is definitely something that we're going to work on and will start working on as soon as Spectrum is operational and is so to say, successfully launching to orbit.
Do you already have customers lined up to get stuff into orbit?
Yes, so very early, I think 3 years ago already, we've signed our first customer, which is Airbus Defence and Space. So it's also kind of a well-known name in the industry, I guess. But we've also signed contracts with quite a variety of satellite constellations and also of providers. One example is Aurora Tech. They're based in Munich. They're also a spin-off actually of the Technical University, as we are. And they're building a satellite constellation for wildfire detection.
This is basically your first launch vehicle. Are there already plans in motion to do like maybe a second larger one to get into a higher payload capacity range?
So we're at the moment fully focusing on Spectrum and getting Spectrum in flight mode, so to say, and in operations. What comes after it, we need to see. I think it's definitely worth thinking about it, but at the moment we're, as I said, fully focusing on Spectrum and getting Spectrum to orbit.
When we talk about companies from Europe trying to get into space like you guys, do you feel like there is a lack of support from politics or the public compared to how the situation is in the US or China or India for that matter?
Well, I think in Europe we do very clearly see at the moment that the system that we were working with, which is institutional development and mainly, so to say, putting all forces towards one launch vehicle, does not really help us, because now we're at a situation where we do not have one launch vehicle left to launch our own satellites, right? And that's exactly also what we want to change with Isar Aerospace, because we say that Europe has, so to say, the opportunities to grow and to become a relevant player in the international market, but we need to change how we do space, and that's exactly what our mission is, bringing commercial space and bringing commercial launch vehicle to Europe, and basically bring Europe back to the international competition.
In order to do that, one day we should probably also try to launch people ourselves and not rely on other countries to do that. Is there like some idea you guys have to take part in such a project?
Ideas definitely, and I think visions too, but as I said also before with regards to a bigger launch vehicle, at the moment we're fully focusing on Spectrum because that's now the most important thing for us, and let's see what comes after that.
What was like the biggest hurdle so far to overcome to get Spectrum to where it is and where it's going to be?
Developing a complete launch system and a complete launch vehicle in-house comes, I think, with quite a few challenges. But I think one of them that we have, which is high vertical integration, that means that we also build up a complete production, right? Designing is one part, but then actually also building the capacity and building the processes to be able to manufacture and to produce all parts that you're doing. That's, I think, also one of the biggest challenges that we had, but that we quite successfully overcame. And we have built up, I think within 2 years, a completely automated rocket engine manufacturing. And at the moment we're also, or now we're also able to produce our structures ourselves. So we've progressed amazing on that end. And I think that's also one of our USPs, definitely.
We hope that you can get Spectrum into space, and I wish you all the best of luck for doing so.
Thank you very much. Thanks for the talk.
Since we talked, Isar Aerospace announced that they have signed a deal with the European Space Agency, which grants them 500,000 euros of additional funding under ESA's Commercial Space Transportation Services and Support Program. These funds will be used to develop test rigs and expand their production facility in Germany. Good on them! Can't wait to see what they're going to do with that. Also, German language channel Mars Chroniken recently posted a tour of Isar Aerospace's facilities. I'll link to it in the description below if you're interested in that. And last but not least, I want to talk about Space. While the other companies I talked about here deal with getting payloads off of the surface and into space, Space product just gets started right after separating from the launcher. That's because they have created a so-called Jetpack, a propulsion module that comes in 3 sizes for satellites ranging from 100 to 200 kilograms. Basically, it's a plug-and-play, or rather plug-and-orbit, platform that integrates with the de facto standard for small commercial satellites, the EELV Secondary Payload Adapter, or ESPA. Space developed their own thruster, which they claim is the world's smallest deep throttling engine, with a thrust level ranging from 5 to 50 or 20 to 200 Newton. That's just Newton, not kilonewton, which rocket engine thrust is usually measured in. And if you go really big, SpaceX's Raptor engine, for instance, has a thrust rating in the meganewton range. That's a million Newton. Just so you get a bit of feeling for how small we're really talking here. But then again, small commercial satellites are a booming business, and I can imagine that Space are filling a demand here that will help them get a lot of new customers in the coming years. Alright, that's today's roundup for European companies trying to get a slice of that trillion-dollar space economy pie that's out there beyond the atmosphere. What do you think? Which of these show the biggest promise? Who of them will reach orbit first? Let me know in the comments down below. And if you want to see more videos like this, make sure you subscribe and leave a like, so YouTube's almighty algorithm learns that it should show you upcoming videos in your feed. If you enjoyed this video, please subscribe to my channel for more and follow me on my social thingies. The links are in the description. Thanks for watching. Goodbye.